Greetings to every one of you. So in this video, we are going to discuss two important concepts from operating systems. One is multi-level queue scheduling and another is multi-level feedback queue. The first one, multi-level queue scheduling, in which in general all the processes which have arrived are inserted into the same ready queue, irrespective of their significance and the type. The processes may be of any type or its importance may be that is differ, but we are using only same type of queue. This is not right way. So multi-level queue is one of the solutions which addresses this problem. So have a separate queue for the different type of processes. See, for example, we have processes of different priority based upon the significance, based upon the importance. We have assigned this priority. So low priority processes like batch processes which normally performed in the background of the system, normally they have the low priority. Similarly, the interactive processes may be of medium priority with the low medium priority or this high medium priority processes are there. See, for example, online processing. So like a banking transaction is going on. So it is an interactive process, or a person is playing a video game. It is an interactive process. So what will happen, how fast it should be that is responded for that particular process. Okay. So that based upon that importance, we categorize the processes into the different types. So medium priority of the high, and similarly we have high priority processes. So any kind of the system processes which earned its significance. See, for example, any interrupt that is given by the system, that should be responded by the CPU immediately. Okay, so it is the order of the preference or the significance. Okay, so here we have 4 queues, that is ready queue 1, ready queue 2, ready queue 3, ready queue 4. So in case of this multi-level queue scheduling, we have different queues for the different types of processes, and again these different queues may follow the different types of scheduling policies. See, for example, the first one follows first come first serve, the second one follows shortest job first, the third one follows shortest remaining first, then the last one round robin. So it may be in any order, but again everything that is done by, that is processed by the CPU, the processor. Okay. In this case of this multi-level queue, we have a problem. So what is that? Let us consider the system processes are keep on coming. So many processes are continuously coming. So that being the case, what will happen? The low priority process may be put under wait state for very long time. This is a problem. So we don't know when will this batch processing, when will this low priority process will get the processor. So indefinite time, the process will be put under wait. This problem is called as starvation. How this problem can be removed? How this problem can be solved? So for that we have a concept, we have a remedy. It's called aging. So aging is it is a process of just changing the priority of low priority processes and promoting or increasing the priority gradually from low priority to medium priority to that is high priority. So changing the process from the queue, that is low priority queue, to this high priority, that is medium priority. So then medium priority to this high medium priority, then just changing the queue to this, changing the process to this high priority queue. So this is this can be that is done. This is what is called aging in general. So one solution to do this, it is multi-level feedback queue. So as I said, starvation is a problem occurs in multi-level queue, that is the low priority processes are put under wait state or block state for a very long time indefinitely because of the continuous arrival of high priority processes, that is system processes. So this may be eliminated by the mechanism called the feedback. So based on the feedback, the process priority can be upgraded gradually, not immediately. So with a fixed time of interval, this the upgradation can be that is performed on the processes by means of changing the process from lower priority queue to this higher priority queue. So for example, if the process is here and that will be that is moved to the next queue. As a result, the low priority process has completes its execution after some time, certainly. Okay. So how this can be that is implemented? Let us see. See, for example, we have the process. Let us consider we have a process, that is process 1. This particular process is waiting for very long time. So what will happen? The feedback is nothing but taking this process to the next level. For example, here let us consider a fixed time quantum of 3 milliseconds. Let us consider this process 1, which need 18 milliseconds to complete its execution. So let us consider this process, that is a queue or queue, that is ready queue 1. It has the time quantum of 3 milliseconds. So what will happen after 3 milliseconds of time, the process will be that is taken to this ready queue 2. So that is process 1 originally, that is 18 milliseconds it needs, but what will happen, it is allowed for 3 milliseconds of execution. So remaining we have 15 milliseconds of time. So with the 15 milliseconds of time, again the process enters into the next queue, that is interactive process, that is RQ2. So here you will get process 1, but now the process needs 15 milliseconds of time. Originally it was 18 and now here it needs 15. So here we have a time quantum of let us consider 5 milliseconds. So what will happen here, this 15 minus 5, again the remaining process time will become the distance. So again that will be, that is now the process 1, it is transferred to the next queue, that is RQ3. So now here process 1, it needs 10 milliseconds of time. So here the time quantum of let us consider that is 8 milliseconds. So it is allowed for 8 milliseconds for performing its processing. So that is 10 minus 8. So here now it is 2 milliseconds of remaining time. So again now it is the process, it is transferred from this high interactive queue from to this high priority queue, that is here let us consider the process 1 needs only that is 2 milliseconds of time. Here let us consider that Q is equal to 10 milliseconds of time. So what will happen at last, the process completes its execution. Okay. So this concept is what is called the multi-level feedback queue. So if the process is waiting for a very long time and that process priority is improved, gradually increased by means of moving the process from one queue into then another queue, and finally which can be that is performed its execution totally completely. Okay, I hope you understood the concept. So what is the importance of this multi-level queue, and I said about the problem what is called starvation, and also the remedy called aging, and how this can be that is implemented with the help of this multi-level feedback queue. And I just gave an example how a process, a low priority process, can be that is executed with the help of this multi-level feedback queue. Keep watching. Thank you for your support.